When I first started out as a software engineer, I became obsessed with perfectionism. I thought if the feature I was working on had an error in the console log, or it wasn't performing to its full potential, well then it didn't quite meet our quality standards. And it became an obvious signal, to me, to others on the team, that a refactor was needed. But ultimately, we just wouldn't ship it. And this created problems in other areas within the project and team. Deadlines would be pushed back and delayed. Stakeholders would have to replan our sprints. And features that we promised to deliver to our users would go undelivered. Looking back, there were fundamental problems with this line of thinking. By not frequently shipping code, software engineers like myself, and you perhaps, can often lower the team's momentum, velocity, and productivity. Focusing on perfection is not always achievable in software engineering. And in today's video, I will explain why being imperfect as a software engineer is A-OK. What if I was to tell you that the biggest websites and platforms in the world are serving billions of page views every month and are shipping buggy, broken, and often highly imperfect code? Code that is full of bad practices, code that exposes vulnerabilities, accessibility issues, and others that cause performance bottlenecks. Now wait. How can this be? Well, some companies with hundreds, if not thousands of employees, with gigantic engineering teams, containing rock stars and ninjas and masters of software engineering, still ship buggy code. But wait, don't they all go through a rigorous review process? And yes, they do. The problem is they still push buggy code into production. Now, why do they do that? They don't do it intentionally. They do it to keep up with momentum. If there are a few exposed console log errors in the browser, but the team was able to acquire 10,000 more users because of the new feature they just launched, which allowed the users to do so, then thinking about it, it was worth it. Errors or not, it was worth it. It didn't prevent them from launching the feature. It also didn't prevent users from accessing the feature. So it's a win. Although you'd think they'd have some sort of checks and balances in place to either strip away the console logs or prevent it from building if there was an error. But regardless, the feature's out, it worked, now they can turn around and iterate on it. Now, this is a good time to talk about the software development lifecycle, or the SDLC, which is a structured approach used by software developers to plan, design, develop, test, deploy, and maintain software applications. There are various models and methodologies used, but generally, the process consists of the following stages. The first is requirements gathering. The first step is to understand the client's or user's requirements, expectations, and constraints. It involves gathering information about the software's purpose, features, and functions. The second is design. In this stage, the development team creates the architecture software design and detailed specifications based on the requirements gathered in the previous stage. The design stage includes identifying software modules, APIs, and interfaces required for software development. The third stage is development. This is the stage where the actual coding of the software begins. Developers write code using programming languages, frameworks, and libraries. During this stage, software engineers work with version control systems to maintain code changes, code reviews, and code quality control. The fourth stage is testing. In this stage, the developed software is tested thoroughly to ensure that it meets the client's or user's requirements and expectations. Testers perform various types of testing, including unit testing, integration testing, system testing, and acceptance testing. The fifth stage is deployment. Once the software has passed the testing phase, it is deployed in a production environment. The deployment process involves installing, configuring, and testing the software in a real-world setting. The sixth and final stage is maintenance. This stage involves maintaining the software in the production environment, including fixing any bugs or errors that are identified in making updates to the software to meet changing users' requirements or to add new features. The software development lifecycle is an iterative process that may require going back and forth between stages until the software is delivered successfully. Effective management of SDLC is essential to ensure that software is delivered on time, within budget, and to the client's satisfaction. So in closing, I asked my robotic friend ChatGPT the following question. Is it okay to not write perfect code? And the results may shock you. As a programmer, it is important to prioritize writing code that is functional, efficient, and that meets the needs of the requirements of the project. While you should strive to write clean, well-organized, and maintainable code, it is important to recognize that software development is an iterative process. This means that code is constantly being reviewed, tested, and refined over time, and it is not uncommon for code to undergo multiple revisions and updates before it reaches the state of perfection. In fact, writing code that is not perfect can be a valuable learning experience, as it provides opportunities to identify and learn from mistakes. And it helps you improve your skills and understanding of programming concepts. It is also important to remember that programming is a collaborative process, and that feedback and suggestions from other programmers can help you to improve your code over time. So, while it is important to aim for quality in your code, it is equally important to recognize that perfection is not always achievable, and that it's okay to make mistakes and learn from them as you go along. So I hope that was helpful. I've been Eric, you've been awesome, and I'll see you in the next video. Oh yeah, and if you like that video that you just saw, then do me a favor and check out the other videos over here, because those are gonna help you, right? Right? I'm right? They should help you? I think they're gonna help you. Yeah, they'll help you. I know, they're gonna totally help you. Okay, see ya, bye.